Swayam Prabha. Digital India. Educated India.
Good morning, everybody. Today we will be discussing a very important application of vacuum in food processing. Food processing is highly required for day to day life, because all of us require food, okay. Water. We have seen water plays an important role in various aspects. But in food processing, water removal is the main concept. So, most of the applications of vacuum in food processing involve drying, freeze drying, concentration, evaporative cooling, such concepts which we know even in our school days, these concepts are known. So, in a way the water evaporation technology using vacuum at room temperature, that is the concept related to the role of vacuum in food processing. Apart from that, there are other applications, pick and place and transporting things like that, and farming the food packaging, etc. That also we will be covering in the next class, but today we will be starting on food processing, the role of vacuum purely from process point of view. The concepts that are going to be covered in this lecture are some introduction to the vacuum food processing, followed by vacuum drying of food, vacuum freeze drying of some specialized foods, vacuum evaporation, concentration of food products, vacuum cooling of fruits and vegetables, and at the end we will try to give some conclusions regarding what type of precautions we have to take, what type of vacuum pumps we are using, what is the latest status of these technologies, and what do we gain from cost point of view or quality point of view. Okay. Now, a little bit of introduction is required for you, because food we all know, in house also we cook food, we store food, okay. We consume food, we store food in various types, sometimes we dry it even in natural drying under sun. All these things are known, but similar things are going on with vacuum in much better fashion. So, vacuum technology that way is going to play a very important role in food industry from a typical application of drying, sometimes refrigerated drying, sometimes concentration purposes, etc. Whatever it is, the vacuum drying is basically a mass transfer operation in which the moisture in the wet solid, that is our food product, is removed up to certain threshold value. You cannot remove up to the 0%, nor you should remove, there may be some requirement. So, there are some standards. How do you do this? By creating a vacuum over it. By creating vacuum, what is it we are trying to do on any food product? If there is water content in that, which is there in every food, sometimes certain vegetables contain huge amount of water actually. That if you want to remove, you have to either heat it up to 100 degrees centigrade, so that you evaporate, or you do something. That something is called vacuum drying, based on the concept that boiling point comes down to room temperature if the pressure on the food containing water is brought down to around 20 to 30 torr. Exact values you can see the vapor pressure of water with temperature. There are tables in the literature or in Wikipedia. So, the main objective of drying or freeze drying is generally to increase the storage life, because today whether it is electricity or food or for that matter money, everything we need to store, because supply and consumption will not exactly match. Now, if you do not properly store these things, that will be wasted, and later when we require more than what is routine requirement, then you do not have food, you do not have water, you do not have money. So, storing is a concept which is very important, from energy, water, all natural resources, food of course definitely. Sometimes storage for 1 or 2 days, sometimes weeks, sometimes months, sometimes years, and this is exactly the point where the high tech like vacuum technology, freezing to deep low temperatures, all these technologies are helping the food processing. Today we will be discussing this vacuum technology help to the food processing. Okay. And while doing this removal of water vapor, on one side we are increasing the shelf life, the other side we are decreasing the weight of it, and if you decrease the weight, you can transport it easily and you can handle it easily. Okay. There are very many applications, but few of them are relevant for a particular application. Some of them are relevant to some other application, but in most of the cases it is only removal of water. There is nothing strict rule, the vacuum can be used to remove anything. Okay. Nowadays vacuum means, initially we thought in other classes air removal. Now today we are talking vapor removal. I hope all of you know the difference between vapor and gas, air. Air even under pressure it will not be liquefied at room temperatures and all. Vapors, the concept of vapor is under pressure it will be liquefied. So, naturally when you apply vacuum technology, we have to see to that you are collecting as a vapor, you are transporting up to the pump, maybe you have to use some condensers inside, otherwise this vapor if it enters into pump under compression mode, it forms water and it spoils pump, though vacuum is the driving force. Those precautions we have to take care of that. In any case, what are the various stages of application of vacuum in food processing or handling of food process systems? Vacuum drying of food, vacuum freeze drying for specialized foods, vacuum concentration and evaporation, both are interrelated. Vacuum cooling of fruits and vegetables. By these 4 processes there are several products like milk made, even the salt that we are using, the fruit juice, concentrated fruit juices, the crystals of those fruit juices which you can add into water and produce juice out of it, and concentration of several chemicals even or energy drinks. So, there are lots of things, even from the day to day products, if dairy products or even fish or meat or any other products that we consume, if we can remove water, it is very good. Okay. But while eating we require again rehydration. Water is very much required while consuming food, water is not good while storing food. This concept you have to keep in mind. Okay. Either you can go for the strategy of deep freeze for storing or removing water by vacuum. These are 2 alternatives. Sometimes you can add both freezing and vacuum, that is called freeze drying. So, in thermodynamic chart we have to deal with pressure and temperature just above the food, in such a way the food is stored for sufficiently long time, or food is concentrated, or food is crystallized, certain liquids are crystallized for our day to day needs. Apart from these processes directly related to food, you can use vacuum for making some high quality packing of foods, that is called food packaging, and even the bottles in which you are trying to store, those things also can be formed by vacuum suction in a hot environment of a plastic sheet, etc. you can form, or you can even evacuate a bag which is vacuum compatible, airtight, and then fill it with some air or gas or something whichever will not disturb your food product. like we have seen potato chips are put in a small gaseous type of sachet, but initially air is removed. And that is why when you open it, after few minutes moisture condenses there, it is hygroscopic. Typically morning cup of coffee that we take, as soon as you open this Nescafe powder and keep it sometime the lid, then the Nescafe powder is highly hygroscopic and it becomes a paste. So, we should not allow it if you want to store. We have to quickly take some spoon of it, add it and immediately close this and stir it. It is so much hygroscopic, it is called instant coffee. Okay. So, all these products like Milkmaid, instant coffee, these are all manufactured originally by dehydrating, and while consumption we have to rehydrate it. In between we have to keep it under dehydrated conditions. Okay. This is what a food process people should know about it. So, it involves processing under vacuum, it also involves storing, packing under vacuum, and certain situations where you have to handle, you have to foil them, you have to label them. Foil handling very difficult by hand, and nor it is allowed in some situations. In supermarket it is just not allowed. Everything has to be handled, packed, stacked, palletized, all the processes are automated. Again there vacuum checks will help us. So, vacuum is playing a very important role in food processing, not only for making some foods or storing some foods or increasing the shelf life without disturbing its aroma or nutritional values. That is important. Just if you want to dry, that is not allowed. If some taste creating things or some good ingredients are also lost in the process of drying, that is not allowed. So, you require a continuous understanding between food technologists and vacuum technologists and the instrumentation experts, etc. So, while the first 4 we will be discussing in this lecture 42, the remaining 4, forming, packaging, modified atmospheric packaging, handling, labeling, stacking, palletizing, these are also related to vacuum for food processing. That will be covered in the next lecture because of lack of time. So, it will be basically 2 lectures. In today's lecture, we will be covering drying, freeze drying, concentration and vacuum cooling. This vacuum cooling is not external cooling, it is the internal cooling created by food itself for food cooling. We will see how it is done. Okay, coming to vacuum drying of food, these things are very nice looking. Here it is like a small box, actually it is sometimes called vacuum oven. We can call it as vacuum chamber, and it is connected to a vacuum pump at a suitable location with gauges, etc. I am not showing all that. There are lots of shelves and there is a gasket here, so that it is leak tight. There is a window through which you can see, and things have to be arranged. Things cannot be just piled up. Then what will happen when you try to apply vacuum, the bottom layers of food products will not feel the vacuum. So, that evaporation will not take place. So, you have to separate the surfaces of these slices, etc. First you have to slice the products as much as possible, and the leafy vegetables or cabbage and many other things, they can be dried easily because they are also porous. Okay. So, under vacuum conditions, the boiling point of water falls to room temperature, thereby increasing the rate of evaporation from the food product. This again and again I am repeating, because you should go into your mind, drying is happening because at room temperature the boiling point, otherwise boiling point of water is 100 degrees centigrade. You have to heat it up to 100 degrees. On one side you are losing thermal energy, on other side some heat sensitive products, they lose some taste, and sometimes they are cooked if they cross 70 degrees. We do not want cooking, we want the food raw materials to be stored. So, it is highly required to remove water at room temperature. So, hygroscopic or heat sensitive products, vacuum drying is highly required. Of course, when you are trying to evacuate, vacuum cooling also takes place, after all it is evaporative cooling. So, some sort of sensible heat has to be added, but this is not to increase the temperature to 100 degrees or anything. 30 degrees centigrade, when you are trying to evaporate by removing moisture, it may come to 25, 24 like that. So, you have to give necessary top it up heating, so that it maintains at that. Okay. That much of light heating is required. In a very controlled way, when food is heated, you may have to heat a food items kept like this in a container. you have to heat with some electrical or some other way, but what will happen, surfaces get heated first, then slowly inside gets, whether it is a potato or a tomato, the inside of the tomato takes some time because it is a bad conductor of heat. So, we need lot of time for drying of net total amount. So, there is a problem here. So, what they do recently, there is a lot of upsurge in the activity of coupling microwaves to the vacuum. Vacuum technology and microwave technology are coupled in such a way, microwave creates eddy currents by electromagnetic radiations, microwave ovens we have seen in our day to day life, that creates certain currents inside the food matter itself. So, heating starts, source of heat is within the food, that way it is uniformly heated up. Otherwise, top surface gets charred and it takes a lot of time. All these problems, nuisance will be there. So, on one side we are trying to remove water, the other side we are also producing little bit of sensible heat produced within the food itself by microwave heating, because these water molecules, they are basically dipoles, polar molecules. So, they get heated up because they try to align themselves with the electric field of the microwaves in high speed, which they cannot do. So, there is a big research, the loss factor tan delta comes into picture, epsilon dash by epsilon, all these things. If you want more knowledge, you can contact us, we can give you some ideas of microwave vacuum units for high quality food storage, etc. You can contact us. So, that is something that is called dielectric volumetric heating. It is called volumetric heating, entire volume gets uniformly heated. Then in that moisture is removed, same moisture is initially before being removed by the vacuum pump, they are doing another duty of interacting with the electromagnetic microwave radiation and producing heat. So, 2-3 things are happening at the same time, there is a lot of modeling of this drying characteristics, etc., which are a multi-physics problem basically. So, and the chamber should be food grade stainless steel chambers. You cannot use any dirty chambers, and the thickness of that should be calculated according to ASME code section 8. Otherwise, under vacuum the chamber will collapse. Forget about drying of this food stuff, chamber will collapse. That should not happen. The food to be dried should be uniformly or evenly distributed here like this. Then only all the surfaces are exposed. It is important in drying technology because drying starts from surface. The heating should be done volumetrically inside. So, both these things are nicely achieved by vacuum and microwave technologies coupled, that is called microwave vacuum heating. Nowadays, this technology is coming up in a big way. Many institutes, R&D organizations are doing lot of research to bring the cost down and to increase the effectiveness, and specialized food products which are so costly, this processing cost is negligible, etc. Whatever way you do, simple vacuum drying or this, you require a vacuum pump. Nowadays, these vacuum pumps are dry vacuum pumps like screw pumps or claw pumps. Earlier people were using rotary vane pumps, but they have suffer from little bit of smell of that lubricating oil, which is not allowed in food. But still, if you can have some cold traps or take care of that, you can still use. But whatever it is, between the pump and the vacuum chamber, this is a vacuum chamber, this is another vacuum chamber, but it is basically microwave oven, but it is a chamber for us. Thickness calculations have to be calculated like any other stainless steel chamber. There will be a condenser between the pump and the vacuum chamber, so that water vapor that is coming out to make the drying of food product, that should not enter into the pump, it should be condensed here. So, accordingly some chilled condenser has to be designed. So, the vacuum drying involves a high quality stainless steel vacuum chamber whose thicknesses etc. are calculated properly, with a quick opening door where inside the lot of shelves are there, you can arrange nicely, and a good gaskets etc. Little bit of heating can be done by electrical or a microwave heating, and then beautiful couplings with connecting this chamber or drying chamber to the pump via a condenser. So, condenser, pump, interconnecting pipes, chambers and certain shelves, and all these things have to be properly calculated, heat and mass transfer calculations have to be done. Okay. So, condenser location between dryer, where to locate, and how do we achieve this dielectric volumetric heating by clubbing this microwave technology with vacuum drying, and how, when to use. If it is not a heat sensitive product, you do not have to use, and up to what temperature you have to heat. Accordingly, the vacuum level decides. Okay. That is how the material itself produces heat in the microwave heating, but drying time and energy consumption, these are to be decided by the design engineer. Finally, you have to save time, save money and increase the product shelf life and quality of the product, so that when you rehydrate it, it is a perfect food. So, there are so many constraints in food processing, which is possible with vacuum drying along with certain other technologies like microwave heating. This is simple drying, but of late something else is happening in the market, that is, you not only dry using vacuum pumps, before that you freeze it first, the product to be frozen. If you are drying only with using a vacuum pump, what will happen is boiling point comes down, so water evaporates, but in the process the product also may collapse little bit, okay, because it is at room temperatures, and the product is taken from the harvest. Product is nothing but a cabbage or tomato, such things. Okay. So, at room temperature they are relatively soft, and in that if you remove water, it will try to collapse. Whereas, if you freeze this, then structurally it is very strong, because it becomes a little tough, softness will go, and inside water also freezes. But that water, when you apply a better vacuum than simple vacuum drying, then what happens is water has got a peculiar property, that it can directly sublime from the solid state to the gaseous state without going through the liquid state, if you can maintain the thermodynamic variables like temperature and pressure below the triple point. This is very much possible. So, by reducing the vacuum level, or by improving the vacuum, by reducing the pressure to 1 tar, even 10 power minus 1 tar, 0.1 tar, not just 30 tar, where boiling point is also 30 degrees in the simple drying. Here we have to go to lower temperatures, because product is first frozen at atmospheric pressure. It is very cold, minus 30, minus 40 degrees, that is kept in the vacuum container now. Now, ice has to be sublimed, and it sublimes, but rate will be very slow, but structurally it will be good, and aroma and its freshness, other taste creating things, because of low temperature, their vapor pressures are such that they do not evaporate. In the simple dryings, along with water vapor, some other things also get evaporated. That will not happen in freeze drying. So, freeze, you read out all these things. In pharmaceutical also it is heavily used. There they call it as lyophilization. Here normally it is called freeze drying, because food processing people always like the word drying, because they want to remove water from various products like fruits, berries and vegetables and meat, etc. It is an extension of vacuum drying, and it is good from the spoilage reduction for a longer durations, and some additional benefits are there, of course, with less weight, absence of shrinkage and retaining flavor and aroma. This process is made possible by modern technologies, because freeze drying of food takes place under high vacuum, but there are very good quality pumps like dry screw pumps, like screw pump with a booster pump. This is the photograph I have taken from Bush, and some of the notes also I have taken from them. They are very, this is a good company where they manufacture very good pumps, and they also give good manuals. You can go through it in the net, and they are very good for education purpose. So, that way these pumps, these are the chambers. This again I have taken from Bush vacuum solutions. See how big these chambers are. These are simple vacuum chambers created by these pumps, and inside you are putting trays where food is distributed evenly. They will be stored, and initially these will be frozen in a deep freeze minus 40, minus 50, and stored here, kept in shelves. Afterwards, when pump is on, you have to reduce it to very low pressure, 0.1 tar. Then what will happen is the ice crystals from this food will sublime directly into this. Okay. That creates a very beautiful end product without any shrinkage. Okay. Structure remains unchanged. Dried cells can easily absorb water again during rehydration, provided after evacuation, after primary drying or after secondary drying, you have to enter, you have to vent the whole thing with a dry gas. You should not vent it with atmospheric pressure. When you want to take the products out, you have to vent it with a dry gas, like inert gases like argon, etc. Otherwise, what happens? Moisture again condenses. Idea is to remove moisture, that has to be taken. There are two drying processes. One is primary drying, which I have told you, freezing, keeping it in that, and taking the vacuum out of it, and it dries by sublimation. And secondary drying is after last few molecules of water which are tightly bound, they cannot be removed by only sublimation. So, what we do is we try to make the vacuum still better, and under those vacuum conditions you try to heat up the material to the freezing point. That means, let it liquefy and all, it will evaporate easily, but vapor pressure is so low because at the freezing point. So, we have to go to the very low vacuum levels. This is called secondary drying. With both these dryings, you can get a final product with almost 2-3% of water left over. So, these things can be stored for a longer time, months together. That is the principle behind this. So, it looks like that. I have explained already this one, you can go through this. Basically, the product to be freeze dried is kept at -50 to -40 in a deep freezer, and afterwards it is kept here in the shelves and vacuum pump is on, but in between you have a condenser. But this condenser temperature should be such that at this temperature your anti sublimation goes on, that means it is gets solidified. So, it should be -70 degrees, because it is -40 at the initial stage we have put, and slowly it gets heated up, and while drying is going on, sublimation is going on, some cooling also will take place. If necessary, you have to add little bit of heat. This temperature control is a instrumentation game which you have to take into account. But in the process, when the sublimation water is going out finally, sublimed water vapor directly into the vapor phase, it should be recondensed. Otherwise, it will enter into this combination of dry screw pump with roots blower. So, this is -70 degrees, this is a condenser. So, you have to condense it back, and at the end, of course, there will be lots of valves to isolate various sections, and you vent it with an inert gas and take it out. So, primary drying is sublimation, secondary drying is after everything has been removed nicely without structure collapsing, most of the water is removed, but deep waters inside cells, etc., they can desorb, and we need to bring the temperature to high, but vacuum level should be further improved at the same time. That is called secondary drying. So, both these dryings together, you can go through these things. There are very good articles on these things in freeze drying products. So, unlike simple vacuum drying, freeze drying is working on sublimation principle, normal drying is working on evaporation principle. Both of them are low temperatures. So, high temperature cooking does not take place, no spoilage takes place, no aroma will go out, and it will be stored as a raw food material. Okay. And you can always process it, whether it is a coffee powder or whether it is a meat or vegetables or tomato or anything, you can store it nicely for an extended time. Either this, depending on the cost of it, you have to go for either vacuum drying or freeze drying. Okay. Now, there is a very simple application. I do not have to take much time here, because it is day to day life, like we need salt, we need milk, we need sauce, tomato sauce. Any restaurant, these three are available, and these three of fine quality are always created under vacuum. You might have seen some packets containing vacuum evaporated salt, very pure salt. That means, basically the salt water from the sea is concentrated heavily. Finally, you put a, there are various names of that vacuum concentrated final amount of thick water, salt water. Okay. That sometimes people brine, many names are there, that will be highly concentrated. Similarly, milk with lots of processing, pasteurization, all those typical technologies are over. Finally, they are concentrated heavily, so that their shelf life increases, like that is a popular name called milkmaid, concentrated milk. And similarly, tomatoes, you have to make juice instantly, but if you want to have 5 months, 6 months this, you cannot do that. You have to create a squash of fruit juices or tomato sauce. How do you do that? You have to remove lot of water vapor, but without removing taste creating whether you call it bacteria or minerals or whatever, that should not be removed. Taste creating things or that flavors, all those things should not be removed, only water has to be removed. So, that is how it is basically evaporation of loose water, so that it becomes concentrated. These concentrators are commercially available. They use dry screw pumps and claw pumps. Earlier they used to use water ring pump or rotary pumps. Even now water ring pumps are used for small scale, but screw pumps are coming to the market in a big way. Claw pumps are coming with a little bit of roots blower. They can be easily made with a high pumping speed in 1 to 30 millibar range. Well, of course, we have to use food grade stainless steel for all these chambers. So, this sort of plants very large scale, they are commercially available and they have to be designed according to your application, maintaining all that mechanical design of the thickness, thermal design, how much is the heating control while drying is going on, what should be the pump, and that water vapor should not enter into the pumps and condensing in traps. All those precautions you have to take for all these 3 products, whether it is a sauce, whether it is a condensed milk or a salt. And you have to make it cost effective, then only you can sell, otherwise they will not accept these technologies, but today they are all cost effective technologies. So, it is a pride sometimes for vacuum technologies whenever they look at vacuum evaporated salt, vacuum condensed milk and vacuum processed tomato sauce. Without vacuum these things would not have taken place, because if you want to concentrate you have to heat it up. Heating will spoil it, tomatoes get cooked and along with milk, water vapor, some other taste creating things of milk also will evaporate, that is not allowed. Okay. So, these things have to be taken care of, that is concentration. Now, towards the end recently there is another big trend, that is vacuum cooling itself. Cooling means the product which is basically sort of porous type of things like cabbage, lettuce, spinach, etc., they contain lot of water. So, if you try to keep in a vacuum box, or first you create in a box, locate it in shelves and apply vacuum, what will happen? The evaporation takes place from the material itself, from the food product, but this time we will not add any sensible heat. Then what will happen? The evaporative cooling starts taking place. This should not be confused with vacuum refrigeration, where using steam jet ejectors etc., with evaporating waters with lot of heat exchangers you create a refrigeration. It is not vacuum refrigeration, vacuum cooling they are called, but it is also refrigeration, but not the external refrigeration. It is not like godowns where you are having cold storage. The cold is produced by external refrigerator. In food vacuum cooling, the food itself will produce its own cooling by virtue of its water evaporation. So, 2-3 things are happening: water removal. So, first advantage, weight is reduced, water is evaporating, so shelf life has increased. In the process of evaporation, the remaining body of it, the free energy, the thermal energy will come down, because water evaporates taking energy from the rest of the body itself. That way the rest of the body, which is our food product, that gets cooled down. So, in the process storage life will further extend. So, you can transport from a freshly plucked things like leafy vegetables or any spinach or cabbage from the field up to the processing center or up to the consumption center, you can take it, creating field freshness. This is called field freshness, and uniformly the food is refrigerated. If you keep it in a freezer, first surface gets refrigerated, then slowly it will. That takes time, which is not good, because time is also very precious for us. Whereas, if it is getting cooled by itself, by its own vapor coming out, and every nook and corner there is a refrigerator sitting. So, whole thing is multiple micro refrigerators within the cabbage itself. All of them are evaporating, all of them are producing evaporative cooling, all of them are reducing the water vapor, okay, and without any damage to anything. And sometimes you can freeze it to very low temperatures and then dry. So, lots of things can be used. So, it is a vacuum freeze created by vacuum cooling out of evaporation only, but 2 things are happening: one is vapor removal, other is cooling is also. So, this is without any external refrigerator, under vacuum conditions. The evaporative cooling is used to produce vacuum cooling. well, lack of time I will not be able to explain, but commercial vacuum coolers are available, they look like that, and they facilitate handling of the semi portable or any such food products almost with a near field type of freshness, field freshness, that is the most important thing. So, you can ship to long distances or to the market area without any degradation of the original flavor that is there on the field, that is how it is there. And sometimes some people are now trying to crazily try to use this cooling of a hot curries that are being prepared so hot, before you serve it should be little cooled, you do not have time, you can apply this vacuum cooling, just evacuate, some bit of water left over will evaporate, it produces cooling, the hot curry gets cooled down, hot things cooked products also can be cooled. So, several experiments are going on in food technology. So, we have seen food drying, food freeze drying, food evaporative cooling, food concentrations. So, several ways. There are other things we need to see like vacuum forming and vacuum packaging, file handling, stacking, there are mechanical operations like palletizing etc., that we will see in the next lecture. So, what we have seen in this lecture, vacuum technology is playing an important role in modern food processing, that is what we are convinced. Around 30 millibar absolute pressure, A means water evaporates at room temperature, typical room temperature of 30 degrees without any external heating. Okay. This phenomena is used in low temperature drying of heat sensitive products. Most of them are heat sensitive nowadays, because very costly food products. Vacuum evaporation is also useful in concentrating milk, fruit juice, tomato sauce and salt solutions and many other things which we regularly use, sauces. Vacuum freeze drying is also used in instant coffee powder making, without which our morning will not start. All these things, next time when you look at salt or sauce or coffee or any other processed foods, you should remember this is possible, it has come to our house after a long shelf life because of vacuum technology. So, vacuum cooling is another thing that is picking up like anything with good quality chambers, and vegetables can retain their field freshness before they are processed, because nowadays lots of vegetables are being produced by the farmer, but by the time they go to the processing center, it is a lot of time that lapsed already, and in the process freshness is gone. So, you will not be able to get a output better than a vacuum cooled processed products. So, by cooling you are taking this raw material up to the processing center by vacuum cooling without any additional refrigeration from the outside, and also removing moisture. All these processes you are utilizing using vacuum, so that field freshness is retained, so that food processing can be more efficient. So, in the next class we will see the other operations of lifting etc. Thank you very much.